Hello. In this video, I want to go ahead and start looking at substitution. So each of the following forms can be integrated using the substitution of u equals f of x. So the form is over here, and the result that you would have is over here. So the form of something that we're going to take the integral of is the integral of some function to the nth power times the derivative of that function on the outside, dx, where n is not equal to -1. Notice that this is very similar to the chain rule. In fact, it is the chain rule. So here, we're kind of missing the n over 1 here, the n out front. Sorry, the n plus 1 out front. Now, over here, the result would be to let u basically be the function itself, f of x here. And we're going to wind up with this, u to the n du. Notice that this is very difficult to see, but over here it's a lot easier to see that you can just use the power rule for integration. So this gives us u to the n plus 1 all over, oops, sorry, that plus 1 should not be there. It should be in the exponent. That is a mistake. There we go. U to the n plus 1 in the exponent here, all over n plus 1 in the denominator, plus c. So this is just the power rule. That's all it is. But once you're done with that, replace the u with what it is, which is f of x. Now down here, if you have some quotient and you have the denominator and then the numerator, and if you notice the numerator is the derivative of the denominator, then you can replace the f of x with u, replace the f prime of x with 1 basically, and get du. And that's going to be basically just the natural log of the absolute value of u, which is the natural log of the absolute value of f of x. And if we have the integral of e to the f of x times f prime of x dx, then we're going to let u be the function that is the exponent. So it's just e to the u, oh, that is not dx, so there's a couple mistakes here. E to the u du here. So it's equal to e to the u plus c, which is just e to the f of x plus c. And that really is it for the substitution. Now, if you notice down here for the substitution method, in general, for the types of problems we're concerned with, there are 3 cases. We choose u to be one of the following. So basically, u is going to be either the quantity under a root or raised to a power, the quantity in the denominator, or the exponent on e. And that is pretty much it. Remember that some integrands may need to be rearranged in order to fit one of these 3 cases. So it does happen. Now, here's the thing. With integrals, it's actually less common to be able to actually do an integral analytically, which is what this is called, than otherwise. And there are just huge tables, just like textbooks full of just nothing but tables of integrals. They're called integral tables. And if you have a certain form, some person somewhere may have already determined what that integral is, and you can always go look it up. But for these, we're not going to need the integration tables because they're all going to be in one of these 3 basic forms. And once you get this idea behind what's happening, you'll be able to, use it and see what you do with it. Alrighty. Well, I believe I'll end the video here, and I will see you in the next one. Have fun.